Hey guys, Lockie from Focus Performance Train, and this week I'm going to dig into energy production. We're going to piggyback off last week's, being lactate and lactic acid. So last week I touched on lactic acid and lactate, and then throughout the week I tried to disseminate the difference between lactic acid and lactate. To clear it up, lactate is the production, or what the byproduct of anaerobic glycolysis. It's in the muscle. It then turns into an acid when it takes a hydrogen ion and goes across into the bloodstream. So that's when we get lactic acid. So this week we're going to look into the three main energy production, or the three main forms of energy production, being direct phosphorylation. That's going to be a hard one today. Anaerobic glycolysis and aerobic glycolysis. We're going to break down when they're used, approximate time frames, and how much ATP they give. So to start off, ATP is adenosine triphosphate. Adenosine triphosphate is the fuel source we need to use to let our muscles contract. Every muscle contraction that we do uses ATP. There is no question about that at all. I don't care if you're on a keto diet or whatever, your muscles need ATP to contract. So the first energy source and the most immediate energy source being phosphorylation, or direct phosphorylation. I'm probably not saying that right, but bear with me. This lasts in total less than 15 seconds. The main fuel source is creatine phosphate, which is in the muscle cells. So this energy system uses all the resources that the muscle cell has to itself. Not external from the bloodstream, whatever like that, just everything that's inside the muscle cell itself. Muscles store, so creatine phosphate is the main source, alongside any of the ATP that is stored in the muscle cell itself. Now, the muscles generally store 2 to 3 times more creatine phosphate than they do ATP. And this is why supplementing, or using a supplement called creatine or phosphate creatine, whatever you want to call it, is so beneficial, because it increases the amount of creatine phosphate available for our bodies to use. So if we're looking at creatine phosphate supplementation, we're looking at really supplementing or trying to improve performance in those 15-second bursts, so we can really get the most out of it as possible. Given that the first sort of 5 seconds will come purely from ATP, and then the rest of those 15 seconds will most likely come from the creatine phosphate donating that phosphate molecule, so that we can get ADP, which is adenosine diphosphate, back to ATP, being adenosine triphosphate. So ADP, adenosine diphosphate, 2 phosphate molecules, and adenosine triphosphate, 3 phosphate molecules. Okay, so that's our first most explosive energy source, being phosphorylation, or direct phosphorylation. The second one being anaerobic glycolysis and lactic acid production. So this occurs without oxygen, either in the presence or not in the presence of oxygen. Now, when our muscles contract really intensely, they can create a blood shunting, or a blood restriction effect around the muscles, creating an anaerobic environment. This generally lasts for 30 to 40 seconds. And it can get a little bit further in those who have been trained. Like I said last week, we can train our body's ability to work through and to buffer the build-up of lactic acid in the blood. So we can build up that ability to buffer that out and get it out and use it as a fuel source with other muscles. So the catch with this one though is, while it's a lot quicker than aerobic glycolysis, i.e. 2.5 times faster, it produces about 5% as much ATP as aerobic glycolysis. That's because it's got to work so much harder and create all these byproducts, and it doesn't have the same ability to pull from glycolysis, oxygen, etc. that aerobic glycolysis does. So it's working a lot quicker at an expense. Everything's like a cost reward when it comes to energy production and all basic physiology. So anaerobic glycolysis is what produces lactic acid and pyruvic acid, or pyruvate. So when glycolysis occurs, we've got glucose that comes in from the blood. It then comes into the cytosol, which is the sort of the home essentially of the muscle. It then goes through glycolysis, where we get 2 ATP, and then we get pyruvate, which then turns into lactate in the absence of oxygen or in really intense environments. And then once hydrogen builds up, it then comes across, and we get lactic acid once that lactate crosses across onto the bloodstream. Okay. Now, aerobic energy, aerobic glycolysis. 95% of our energy, either in resting or low intensity exercise or just daily activities, comes from aerobic glycolysis. Aerobic glycolysis occurs in the mitochondria, which is the powerhouse of the cell or the body. This is where the majority of all energy production occurs. As you can see, 95%. From every glucose molecule, we get 32 ATP. So if we look at this, we get, I think from anaerobic glycolysis, we get 2 ATP. We get 32 ATP from aerobic glycolysis, which is huge. So it's a much more energy-rich source, or a much more, not efficient, but more capable source to produce energy when it has the time and the space. Over 30 minutes, some of the research and some of the textbooks I have say that over 30 minutes we tend to use more fatty acids to fuel our energy source, predominantly because by the end of that 30 minutes we're most likely going to have used most of the glycogen, which is around our body. From there, we start to break down fatty acid, which again is a much slower production, and we start looking into things like lipolysis and gluconeogenesis, all that sort of stuff, which can get much more complicated. So the whole purpose of today is to keep it nice and simple. These are the 3 main functions where we look at for energy production. Now, like I said, gluconeogenesis, lipolysis, that sort of stuff happens in this world. It needs oxygen to be there. Okay? So let's look at examples for each one and to what they're actually going to be able to provide. So, phosphorylation, that's looking at your weightlifting movements, very, very explosive. If you're looking at bodybuilding, not so much. We're looking at bodybuilding more here. Looking at the length of your set. 100 meter sprint, we're looking at in that 15 seconds, so on and so forth. Okay? Aerobic glycolysis, that's at 30 to 40 seconds. You're probably looking around that sort of 200 to 400 meter run mark. Maybe not so much 400 meter run, but you're looking at sort of 200 to 300 meter mark for your running in particular. You're looking at sort of sets of 10 to 15 there if you can get them through in under a minute. And those real short, sharp efforts where you're going to be pushing, so like, for example, 30-second max effort on a assault bike. That's going to dig into this big time, and it's going to create a large amount of hydrogen. It's going to create a lot of byproducts from energy production because it's so intense. It's predominantly anaerobic effort. Alright, anaerobic, that's what we're sort of looking at, that sort of 45-second plus mark. And we're at a bit lower intensity, and we're going through and we're able to produce energy a lot quicker. And a really good example of these 3 energy systems is if you watch someone do a 1 minute effort on an assault bike. First sort of 15-20 seconds, they're moving flat chat. They're just no holds barred. Around that 30 to 40 second mark, you start to see things slow down a little bit. They're hitting that wall. And in the last sort of 10-15 seconds, they're just grinding away, trying to get as much out as they can because they're sunk into this. You can see the energy system change. The intensity changes as the body moves through different energy systems because it can't produce energy as quickly to keep up with the demands. So they have waste or byproducts which are caused as a result of it. So this has been a real short, sharp sort of dive into energy production, and sort of, I guess the reason why we should understand this as a basic is to go, alright, what am I going to do today? What am I programming, and what do I need to do to get better at my sport or my goal? And if we're looking at, I think we need to be very aware that we're in that phosphorylation. That word's killing me. And we're going to probably look at supplementing with creatine phosphate. If we look at this world, this is this sort of area here between anaerobic glycolysis and aerobic glycolysis is where CrossFit fits in. You're going to have a lot of workouts where you're going to have to be able to go really hard here, but then you're going to have quite a high aerobic base to be able to produce large amounts of ATP for extended periods of time and not get fatigued. Okay, so I hope energy production has been something this video on energy production has been somewhat useful to you. It's a little bit nerdy. I'm going to start going through some more of the exercise physiology now to try and get some more education out there and try and improve the education. So these basic underpinnings can help you have a better understanding. If you've enjoyed it, like, subscribe, share. It's a really basic video. Got any questions? Leave comments, etc. I'll see you guys next week.